Thanks everyone for joining us today. And today we'll be talking about data preparation as the first step in your machine learning life cycle or pipeline. Before we start, I'd like to have a quick call to understand your experiences, and based on that, we can see how today's workshop is going to go. So let me launch the poll, and please, it's just like 3 questions, so fill them and let me know what's your experience with machine learning and data preparation. Okay, perfect. So yeah, like it seems like everyone are using R as their favorite tool to analyze their data, and R is a very powerful tool. Also, like there's Python. Python is usually the way to go in terms of people doing machine learning because of the amount of libraries available that you can use to build like standard kind of machine learning models, along with like the advanced machine learning models, like deep learning model and large language models and things like that. So Python is usually the programming language to go in terms of like machine learning. Experience seems like we're like there isn't much experience running machine learning models. So I hope today's workshop, along with the upcoming workshops on machine learning, are going to be beneficial and like give you an idea of what machine learning is and how to start building your own models. Data, that was very interesting to me, that like you're dealing with lots and lots of data. So basically what you're gonna like learn today and in the upcoming machine learning workshops is gonna be very useful for you in order to understand how things work and which model to choose and how to clean up your data or prepare it before you building a model. However, these techniques might be like inefficient when dealing with like huge amounts of data, like 10 gigabytes or more. And there, like we have another workshop on how to like use Apache Spark in order to do machine learning on like on data with sizes like greater than 10 gigs. So I highly recommend like looking up for this workshop and signing up for it as well to know how to like process or like build machine learning models on multiple machines, basically in parallel, to speed up the processing of the entire process. Okay, perfect. So now let's start. I'm going to share my screen. So my name is Shadi Khalifa. I'm one of the senior analytics developers at the Center for Advanced Computing. I did my PhD a while back at Queen's University School of Computing, and since then I've been working at the CEC, developing different solutions for researchers across Canada. And basically the purpose of today's workshop is help you out with making decisions on what process to use depending on your data and which model to use as well, because that's usually the tricky part, as we're going to see later on. Today's agenda is going through the theory part of what is data preparation, and then we're going to go through a hands-on part where we're going to process some data from Airbnb, apply the different techniques that we talked about in the theoretical part. And then after we're done, then please make sure you fill in the survey that's going to be sent to you via email. For today's workshop, you don't need any like to install any IDEs or any software on your computers. Basically, you only need a browser, and the instructions for accessing the hands-on exercise are going to follow on the slides. If you have a question at any time, feel free to like leave it in the chat, and I'll be looking at the chat every now and then to answer your questions. Okay, so the first question is, what is machine learning? And machine learning is basically the systematic computation analysis of data. It's a way for having computers go through our data and try to find hidden patterns in it, and highlighting these hidden patterns for us so that we can use these patterns to generate some useful insights to use it in order to predict something or like the likelihood of something happening in the future. machine learning is like the academic name of that science. However, like there are other names that people have been using interchangeably, like data mining, data analytics, and data science, and more or less they refer to the same thing. Machine learning is multidisciplinary. So basically, if you're doing machine learning on genomic data, then you need to have like to know more about like genomics. You need to know about computer science. You need to know about statistics. And the same applies for applying machine learning to any domain. And it's a combination between art and science. So the science part is the mathematics and statistics that basically allows us to actually build these models and do the predictions. However, there's the art part, and that's basically the main topic of today's workshop, when to use each of these techniques. Because the science part, you can like read a book and understand all the mathematics behind a certain technique. However, usually the art part is like comes with experience when you like do lots of like machine learning models or like build machine learning models for different problems, then you would know like which model fits which scenario better. And the purpose of today's workshop is basically focusing on the art part and giving you some insights or like some recommendations on when to use what. And the purpose of machine learning is basically creating a function that estimates the likelihood of a future event based on historical data sets. So we have some data, you use this historical data in order to build a mathematical model, a mathematical function that basically can take a new input and then generate a likelihood of a future output. And like to simplify it, we can think of a machine learning program as a program that comes up with the coefficients of this equation. So basically, X is our input and Y is the output we're trying to predict. So basically, a machine learning algorithm would use the historical data we have in order to come up with a number for a bit like B0 and B1. And based on that, we can basically generate outputs for data that we haven't seen in the past. Okay. So when do we apply machine learning? There are multiple scenarios where machine learning comes in handy. Things like when human expertise are absent, like navigation on Mars. So basically, we build a model that would automate the navigation of a rover on Mars. When humans are unable to explain their expertise, things like how we generate speech, for example. I think all of us have used ChatGPT at some point, and basically, while it's very hard to write formulas that would generate text as human do, it's easier to just build a machine learning model that basically ingest huge amount of like text that have been written by human and then try to mimic that, which basically what ChatGPT does. When solution change with time, so basically if you want something to be adaptive to certain feedback, so machine learning works with that. Solutions to adapt particular cases, so personalized medicine, personalized service at any form. So basically, machine learning also can build a model and then customize it based or customize the output based on the inputs depending on the patient case. And finally, when the problem size is too big for human capacity to comprehend, things like processing all the web pages on the internet and basically like when someone types a certain search keyword, like find all relevant pages to that keyword. So basically there's like that's beyond the capacity of human. And so machine learning can help a lot with that. Okay, so the machine learning process. The machine learning process always starts with data. So if you don't have data, then there is no actually a way for doing a machine learning. And here we're not talking about data in terms of like a couple of megabytes. Here, like we need actually a lot of data in order to do a proper machine learning or like to train and build a proper machine learning model. And data comes in many forms and formats. So the most like common one is an Excel file or like a tabular format, which is called in the machine learning terms a structured format. So basically, when your data is a form of a table that has some columns and some rows, then that's a structured data set. And that's basically what a machine learning model can ingest. And that's like the simplest form of data. For the other forms of data, we need to transform their format into that structured format in order for us to use a machine learning model on them. So, for example, there's type of data sets that's called semi-structured. And these are data formats that have some structure in them, but they're not in a table format. For example, if you have a log file generated from your software or like from your hardware, and basically, usually a log file has a date, it has an event, it has a risk level, or like whether it's a warning or an error along with a message. However, it's not put in a table format. Same thing if you're dealing with an XML file, with a JSON file. So basically, all these files have some structure in them. So basically, there is a field and a value, or a key and a value, but they're not put in a table format. So for us to like use these files or like use this data in our machine learning process, we need to transform them first into that table format in order to actually be able to use them with the machine learning models. And then there are the non-structured file formats, which are things like Word documents, PDFs, emails, tweets, Facebook posts, images, audio files, and whatnot. So basically, these do not exist in a table format. And depending on the format of these non-structured data sets, we need to implement a process in order to transform their format from being non-structured to being structured in order to be able to process them using machine learning algorithms. So once we identify our data set, then we start our process. The first step is doing business understanding. So by business understanding here, we need to ask ourselves some questions, things like what are or like what is I'm trying to achieve with my data set? Am I trying to understand what happened in the past, or am I trying to build something to predict something in the future? We can also ask some questions like what the terms in my data set mean. Like if I have like a computer science background and I'm working in genomics, then basically I need to ask like the domain expert, what does a gene mean, or like what are the different terminologies in that domain mean. And based on that, I need to understand these before I even start working on this domain. Of course, it's easier if you are the domain expert, uh, as opposed to being a computer science expert. It's like that the business understanding part can be easier when you're the domain expert because you already understand everything. And that's why we have these workshops where basically we try to empower the domain experts to do their own machine learning process as opposed to having someone from computer science doing these processes, because at the end of the day, the domain experts knows way more about this business or about this domain than a computer science person knows. And so it's easier for a domain expert to learn machine learning for like a computer scientist to learn everything about a certain domain. So once we do the business understanding, then it comes the data understanding. In the data understanding part, we take every attribute in the data set and we try to understand it. And by understanding it, we mean that we try to understand what are the values, like the valid values for that attribute. So for each of these attributes we have in our data set, let's say we have some ER data set, and we have like the patient age, the patient blood pressure, and like some other information as well. So for each of these attributes, we try to understand what is the central tendency of these attributes. So basically, what's let's say, the average of the values for that attribute, along with the spread of that attribute. So basically, what is, let's say, the standard deviation, for example, of that attribute. And by understanding these two values, then we can understand we can know if there are some invalid values in our data set, or like if there are some outliers in our data set that we need to process separately, as we're going to talk about that later on. So with data understanding, we take each attribute, we try to understand how this attribute behaves, the values within that attribute, how they behave. And once we do that, then we start like studying how each of these attributes relate to the other attributes in our data set as well. So are they like positively correlated with one another? Do they change in a certain way when like the other attribute changes well, and so on? So basically, we try to understand the relationships between the different attributes we have in our data set. So once we understand our data set, then comes the process of data preparation, where basically all the problems we discovered in the data understanding, we try to solve using different techniques. And after we solve all these problems, we start doing something called feature engineering, which basically means that, like, yes, we have some raw attributes coming from the data set, but we want to generate more meaningful attributes that we can actually like can give more information to the machine learning model. So, for example, if let's say we have like a shopping cart of some sort, and basically like we can have like a data set that has like this person came to the supermarket and like paid like $100 for like their cart and so on for every day. Like this information might be okay, but it's not really useful. What we want to do is like the frequency of that customer, right? Like how often do they come, and basically what's the average spend per visit. So we can do like use feature engineering in order to generate these new fields for each of the customers we have, and then use these new fields to train our machine learning model, which basically hold more information than just the raw data we have. So that's basically the feature engineering part. And once we're happy with the features we have, then we can start the modeling, which basically building the machine learning models. And my colleague Amal Khalil will be talking through the modeling in tomorrow and the day after workshops. So basically, that's when you start like using the data that you've prepared to build a machine learning model. You evaluate that model, and there are multiple ways to say like yes, like my model has achieved the accuracy that I'm happy with. And once that happens, then you can deploy it and start using your model on data that it hasn't seen before. So basically, trying to predict or forecast something new. This process is iterative. So basically, like at any point in time, you can go to any of the other previous processes if you're not happy with the results. And it goes in multiple iterations until you're happy with the results and you can deploy your model. Modeling is the most computational and memory intensive process in this life cycle. So unless you're running on a very small data set, usually your laptops is not powerful enough to actually run or like train a machine learning model. And in such situations, you can use services like the ones offered at the CEC, the cloud computing services, or any of the public cloud services like Amazon, Microsoft, or IBM, Google. So each of the cloud providers, they offer machines of different computational power, and you can basically use any of these services to do your modeling. The data understanding and data preparation parts are the most like human intensive processes, and these two processes usually take 50 to 70% of the project time and effort. There are ways to automate these processes. However, the automation of them is very computation intensive, and usually they don't yield very good results. And so these need to be done manually, unfortunately, and they take lots of time because you need to look at each of the attributes, study it, and then see its relationship with the other attributes, see what problems are out there, along with fixing these problems and generating new features in order to use them in your modeling. And you're gonna hear me say this a lot, but basically, if there's garbage in equals garbage out. So if you just take the raw data as is and throw it at a machine learning model, then yes, you're gonna train a machine learning model. However, the accuracy of that model is gonna be very bad. So you need to work on your input, your raw data, transform it into a better data set, a data set that can generate better insights, and then you would use this like prepared data set to train your model in order to get a model that achieves the accuracies that you need in your challenge or like in your solution. So as I've mentioned, data comes in many forms and formats, and at the end of the day, we need to put the data in that table format or like in this matrix format where each of the rows represent one of the subject or one of the examples, while each of the columns represent one of the attributes we have in our data set. And for non-structured data, we need to transform them into that structured format. So let's take an example. So if I have a number of documents and I want to build a machine learning model in order to understand these documents. So how can I transform a Word document or a text file into this matrix format? Any suggestions? So a text file consists of words, right? And to differentiate between different types of documents, we need to basically look at each of the documents, see what words happen there, and based on that, we can build a machine learning model that can differentiate between them. So in order to differentiate between different documents type, let's say documents talking about sports versus documents talking about news. What do I need to do? Or like how can I represent a document in that matrix format in order to build a model that can differentiate between sports articles and news articles? Okay, so in the chat, Jillian is saying each row represents a sentence and each column represents a word. That's close enough. Patricia is saying looking for keywords and assign values which can then be used as data points. Okay. So yeah, so that's very close actually. So basically, like each column is going to represent one of the words, and of course, like we're not going to take like all the words in a document. So things like the, in, on, and whatnot. So basically, we can just like remove these common words that basically we're going to see in all of the documents, and we're just going to use basically the main keywords or like the main words in a document. So each word is going to represent one of the columns. And then each of the rows is going to represent one of the documents, right? And the values in this matrix are going they can represent how many times a word happened in a text, for example. So basically the word ball or referee, like these like are going to have high occurrences in documents referring to sports and less occurrences like in documents talking about news, for example. And so like we can use something like that in order to transform the non-structured text format into that like matrix format so that we can use it to build a machine learning model. For things like images, we can also transform an image into this matrix format. So each row represents one of the images we have, and then each of the columns is going to represent a pixel or the color of a pixel in that image. So the first thing, since an image is a 2D matrix, we're going to flatten it into a one-dimensional matrix, and then basically each of the columns is going to represent the color of one of these pixels, which can be represented from 0 to 255 if this is a grayscale image, for example. For audio, we can also, each of the rows is going to represent one audio file, and then each of the columns is going to represent one of the phonemes, which is the smallest audio segment. And then basically similar to like words, each like the value within this matrix is going to represent whether that phoneme exists in that audio file or not, right? So basically for each of the data types, there are ways to take that non-structured format and transform it into that matrix structured format so that we can then use it to build a machine learning model. Once we transform our data into this matrix format, then we need to assign a data type to each of the attributes we have in our data set. And types, they can be either numeric or categorical. So a numeric, this means that it's a continuous, it has a continuous values, while a categorical, this means it has discrete set of values. For categorical attributes, basically there are no arithmetic operations supported on them, things like January, February, March, and so on. So basically, like it has a discrete set of values, and it doesn't make sense to add January to February Even if, like you say, this is like month number 1 and month number 2, it doesn't make sense to add them. And so even if like you write the month in as numbers, it would still be defined as a categorical attribute and not a numerical attribute. Categorical attribute can be nominal, which means that they don't come in any order, like gender, male, female, and so on. So they don't come in a certain order. Or they can come, or they can be ordinal, which basically means that there's some order in them. Think like if you're collecting survey data. So strongly disagree is lower than disagree, which is lower than neutral, which is lower than agree, which is lower than strongly agree. So basically, there is some order there. Same thing with like the month. So basically, January comes before February. So you can define the month of the year as a categorical ordinal attribute if you want to keep the order data in your data set. For numeric attributes, basically these have continuous values, things like the price or things like the score, a test score or something. And they can either be interval or ratio scale. So for interval scale, like numeric attributes, these are numeric attributes that can be added, subtracted, but it doesn't make sense to multiply or divide them. So they don't have a true zero, for example, like saying that someone got 100 out of 100 in a test, that does not mean that they are twice as good as someone who got 50 out of 100 in a test. Basically, like multiplication doesn't work in this situation. So so that's the interval scale. And then we have the ratio scale, which has a true zero. So basically you can multiply and divide. So we can say that 4 grams is twice as heavy as 2 grams. Okay. So basically we need, after we transform our data set into this matrix format, then we need to define the data type of each of the attributes in order then to basically inform the machine learning model how to handle this attribute. So here, for example, we have a number of columns in our data set, and we need to assign a data type to it. So customer ID, it's represented as numbers. However, adding them to one another, like adding customer 1 to customer 256, doesn't make much sense, right? So since arithmetic operations do not make sense, then this means that customer ID is actually a categorical attribute. It has a set of discrete values. And then comes the question, like whether it's like ordinal or nominal, like do I want to keep the order or the order does not really matter for me? Again, like that depends on the problem you're trying to solve. So we might want to keep the order if we were interested in, let's say, like knowing who are our oldest customers. These are like our VIP customers that have been like on our system since forever. So in that case, we would like set the data type for customer ID as being ordinal. If we're not if we don't care about the order, then we can define it as a nominal categorical attribute. In that case, we're going to lose some information, which is the order information. However, we're going to make it easier, or like we're going to simplify the data set for the machine learning model. And so the machine learning model can process the data faster and generate higher accuracies, since it's now like trying to solve a simpler problem. So like defining the data type, it is a bit challenging because on one hand, you want to keep as much information in the data set as possible. And on the other hand, you want to simplify the problem so that the machine learning model would like give you good results and do not do not take forever to actually give you a machine learning model. So for customer ID here, it's a categorical attribute. And now it really depends on what you're trying to do. You can either define it as ordinal to keep the order, or nominal if the order does not matter for you. The same thing applies for the product. For the price, it makes sense to add prices. Like basically I can do or like run a query and give like the total amount spent by a certain customer, right? So basically I'll be summing all the prices paid by a certain customer ID. So it makes sense to add it. $20 is twice as is twice the $10. And so it makes sense to add multiply. And so this means that this is actually a ratio numeric attribute. The purchase month. So here, like it's written in numbers, so you might think that, okay, so like it's numeric. However, it doesn't make sense. Like if I want to like know like aggregate data for a certain customer, it doesn't make sense to add all their purchase months. It might make more sense to get like the most common, that basically like how like which month is the month where a certain customer buys the most from our store. So so basically in that case, since like we cannot add or like doesn't make sense to add these numbers together, then that's a categorical attribute. And if I want to keep the order, then it's ordinal. If I don't want, or like if I want to simplify the problem, then it can be nominal. Finally, the customer phone number. Customer phone number, it says like it's a number. However, it's like it doesn't make sense to do any arithmetic operation on it. And so it's a categorical attribute. And there's no order there. So basically, it's a nominal categorical attribute. Okay. Okay. So can anyone think of engineer out of this raw data? Like now, like we have some data there, and if let's say we want to find out who are our customers that spend the most, can you think of like features that we can generate from the raw data we have that can help our model decide who are like most important customers? Yep, we can aggregate the number of records per customer and get the number of purchases per customer. We can also get the total amount spent by customer. Look, okay. So media is looking for the customers who did like one big purchase and flag them. Alicia, price spending per customer, yes. We can get the most product selling. So basically, instead of aggregating a customer, we can aggregate on the product. Yes. Aggregating per month. So basically create a new column which has the total amount spent per certain month for each customer. Yes. But like, what about the customer phone number? Can we do anything with the customer phone number? Exactly, Patricia. Yep, Trish. Okay. So yeah, so basically, yeah, customer phone number are useless on their own. So basically, I can't actually use anything with a like or like do anything with a customer phone number. However, I can create new features out of the customer phone number. So I can use the area code to basically determine where that person live, and then there are tools online that basically would tell me like the profile of people living in that area, basically how much they spend per month on grocery, how much they pay for rent, things like what kind of cars they drive, whether like how many kids they usually have in this area. And then this information can be used in order to also like find out the customer purchase behaviors. Perfect. Okay, so in terms of data understanding, I'm not gonna like go in depth here because basically that's like basic statistics that like all of us already know. So first you start your exploration with univariate analysis, which basically means that you're studying each attribute on its own. If that attribute is a numeric attribute, then you can study its central tendency using things like the mean, the median, the quartiles, the mod of that attribute. And then you can study the spread by things like the range, the standard deviation, the variance, the interquartile range, skewness, kurtosis. And basically, that would give you an idea of how that attribute behaves, or like the values within that attribute behave. Also, you can use visualizations, things like histograms and box plots, in order to understand the values of a certain attribute. For categorical attributes, you can use the count. So basically, how many like how many people are buying in January, or how many people are buying in March. Or you can also use the ratio. So basically, the ratio of people buying in January. Also, you can use histograms in order to display the values or like the distribution of the values for that attribute. Once you're done with your univariate analysis, then you can start your bivariate analysis, which basically trying to understand how two attributes are behaving relative to one another. So if both attributes you're trying to find the relation between are numeric, then you can use things like Pearson correlation. If it's like closer to one, this means these are positively correlated. Closer to a negative one, then this means that it's inversely correlated. If it's closer to a zero, then this means that they are not correlated to one another. And you can also use scatter plots to basically see how these two attributes behave relative to one another. For categorical attributes, you can use cross tabulation or the y-square correlation as well. Closer to one, highly correlated; closer to a zero, not correlated. You can use heat maps and stacked bars in order to visualize the relationship between the values of two categorical attributes. And finally, if you have a categorical and a numeric attribute, then you can use the analysis of variance or the ANOVA in order to see how one attribute behaves when the other one increases or decreases. So the ANOVA can help you with that. Looking at the results of these statistical measures can be a little bit tricky. So make sure that you look at all the statistics and then decide which one of them you're actually going to use to make your decision. So in this example, we have a company, and when someone asks like what my starting salary would be, so they're saying that their average salary is 80K. And if you look at their data set, like, yes, the average salary is 80K, but that's because the CEO's son is taking like a huge salary while everyone else is taking a lower salary. So in that case, the mean does not mean much, and it should not be used to do your understanding. In that case, like something like the mod would make more sense, or the median would make more sense to use in such situation. Also, like correlation is not causation. So even though two attributes might be highly correlated to one another, that does not mean that one of them is causing the other to behave this way. And so there might be other attributes affecting that behavior. And yeah, like just like that's something to consider when when you're having highly correlated attributes. Correlations are also not good with curves. So here we have an example with temperature and sales of ice cream. So as the temperature goes up, then the sales of ice cream goes up until at a certain point, which is like around 25 degrees, and then the sales starts going down. And if you calculate the correlation between the temperature and the sales, you're going to find it closer to a zero. But basically that does not mean that like we should like ignore temperature from our analysis, or basically removing the temperature column or attribute from the data we're sending to the machine learning model. Even though its correlation with the sales is a zero, we like in the data understanding part, we also do visualizations like the scatter plot we have here, and basically here we see a curve. So we know that like correlations are not good with curves, and what we can do here is that we can split the data set into two parts. The first part is when the temperature is less than 25 degrees, and the other part is when the temperature is higher than 25 degrees, and then recalculate the correlation. In that case, you're going to find like for the first data set less than 25 degrees, you're going to find that there is a high correlation between sales and temperature. It's almost a 1 correlation. And then for the second data set with temperatures greater than 25 degrees, you're going to find that there's a big inverse correlation between temperature and sales, and close to a -1. And basically that means that like probably it gets too hot for people to go outside after 25 degrees, so they stay home, and that's why they don't buy ice creams anymore as temperature goes up beyond the 25 degrees. So just looking at the statistics without looking at the visualizations might make you like not consider certain attributes, like in this example, the temperature. So that's why like I highly recommend using visualizations as well in order to understand if there are any curves in the data set, and whether you might need like to split your data set to better understand it, or like better create better models from it. In terms of visualizations, also, it can be a bit tricky looking at visualizations. So here we have two charts displaying the same exact data. On the left side, this is the government trying to say that they've increased the salaries. So basically, they just like zoomed in the y-axis to signify the $500,000 increase in salaries. While on the right side, this is the opposition. Basically, they zoomed out the y-axis to show that the increase was not that significant. So with any chart or like any visualization, make sure like you zoom in to see if there are any like patterns in there, and then make sure you also zoom out to make sure if these patterns are significant or not. And based on that, make your decision whether yes, like there are patterns there that I'm gonna like use in making up my decision on whether to keep a certain attribute or not. Before, yeah, like so make sure you zoom in and zoom out before making a decision on whether to keep a certain attribute or not. So now we're going to talk about data preparation, which basically is the process of cleaning up the data, giving all the data understanding we've done in the previous process. And then we're doing feature engineering to create like newer features out of the raw data we have that are more meaningful and contain more information that can help our machine learning models to generate better insights. And the results of the feature engineering process is feature explosion, or basically having too many features that not all of them are good. And so the third process in the data preparation is the feature selection, basically deciding which features to keep or like which attributes to keep and which of them to ignore like when going to building the machine learning model. So the first thing is data cleaning. And sometimes it's not that easy because basically we have something called dirty data. And dirty data, this means that the data is there, it's just like it has values outside of the normal range of the attribute. So here, for example, we have the birth date 30/13/70. So since there's only 12 months in a year, then this birth date does not make much sense. And it's very hard to like actually write code to detect things like that. Usually these would require some sort of like a human intervention to look at the dates and know whether like to keep them, whether that's a valid value or not. However, like if you're doing something like a histogram, then you're going to find that there are some records that like basically, or like some patients that have birth dates in like in the months of like month 13. And basically then you can like extract these records and then fix them somehow. So one way of fixing some like dirty data like this one is basically just saying, okay, like if it's something more than 12, then I'm just gonna reset it to 12. So basically these people are just gonna go to December. The other way of fixing that is just like consider this as a missing value and just like delete that entire value altogether and basically just like treat it as a missing value. And later on, we're gonna see how we can handle missing values. Then also, then we sometimes we have phone numbers that have like the same digit over and over. So it can be like all nines or all zeros. And usually that happens when that field is a required field in the user interface. However, the information was not available. So for example, let's say like this is like an intake form for patients, and then the patient did not have a phone number, and the person entering the data, they just basically press the 9 button on their computer and basically just keep pressing it to fill that field. Okay. So again, like you can discover a dirty data like this by running something like a histogram. You're going to find like there are lots of patients that share the same phone number that's like all nines. And basically that would mean that like, okay, so this is not really a valid value, especially that the area code does not match the area code where like most patients are coming from. And in such case, basically, you can just like delete that and treat it as a missing value. Then we have misspellings. So things like Kingston with 3 I's. So for a computer, a Kingston with 1 I is different from a Kingston with like 2 or 3 I's. And so you might also want to like run some sort of like a spell checker on your data set, making sure like any misspelled words can be corrected to their origin. before running your data. Or again, like you can just like run a histogram or like display a histogram, and then like you're probably going to have like some outliers with Kingston with like 3 eyes or Kingston with 2 eyes. And in that case, you can manually fix them, fix the spelling. City equals King Canada. So again, like that's very hard for a computer to find out. So again, that would require manual intervention while you're doing your data understanding and data preparation, basically looking at the histogram, seeing some patients with the city equals Canada. So from your basically business understanding, that means that like this value is invalid. And so that should be fixed as well or treated as a missing value. The last example here, we have three values added to the same attribute or like to a single attribute. So name, JSMIS, and then there is a date, and then there is a city. So basically, it seems there have been like a problem while importing the data into this database. And in such case, basically, we need to split the three values into three different attributes. And so again, like that's very hard to do it automatically. It needs to be done manually. And the way to discover it is again like using things like a histogram or a count or a ratio for categorical attributes. Okay. So that's one of the main issues with data preparation, and that's why usually the data understanding data preparation take 50 to 70% of a project time, because like things like that, like it's very hard to detect. Like with missing values, it's easy, like you already know, like there is no value here, so okay, like I can deal with that. But the main issue is the dirty data where there is a value, but this value is invalid. And so like you need first to be able to find it and then decide on how to fix it afterwards. So handling missing values, one approach is basically deleting an entire row or the entire column that has missing values. However, this is like the last resort. Like we don't do this unless there is like more than 85% of a row or a column is actually missing. In that case, then it might make sense to delete the entire column or row. Otherwise, implementing this approach of deleting an entire row or an entire column basically makes us lose tons of data that we need to build our machine learning model. So if we apply this approach of deleting an entire row, if it has a missing value or like an entire column, then basically instead of just like having 4 columns or like 4 attributes, we end up with just one attribute, which is not enough to build a machine learning model. And if you apply the delete the entire row, again, like instead of having like 9 or 10 rows, now we end up with only 2 rows, which is not enough to build a machine learning model. So basically, we are losing a huge amount of data using this approach. So basically, this is the most simple approach. However, this approach can only be used as a last resort if there is more than 85% of the values in a certain row or a certain column missing. Okay, so what if I want to actually fill in the missing values? So there are other approaches that are not computational intensive and can be used, things like general statistical replacement. So here the idea is that we're going to calculate a certain statistical measure for a column and then just like replace all the values with that statistical measure, right? So we can use like the mean, the mod, or the median, or any other actually measure that you want to use in order to replace the missing values. So in this example, we're just going to use the average. So for the weight, we're going to calculate the average of all the weights and then basically just replace it. Same thing for the height. Same thing for the gender. Gender, basically, we go with the most frequent instead of the average. And that's how we can fill in our missing values. The problem with the general statistic replacement approach is that it creates an artificial bias towards the new value that you've created. So now, like, basically everyone is 195 centimeters tall. So that bias can cause the model to base its decision on unrealistic data sets. And when you do that and deploy the model, then when it sees or like when it tries to process unseen data, then the results are not satisfactory. So a modification for this approach is called the grouped statistical measure, or like a grouped statistical replacement. And in that case, instead of just calculating a single statistical value for an entire column, we actually group the values based on a certain attribute, and then only you like calculate the statistical measure within that group. So in this example, we can group the players by their gender and then replace the missing values by the average within that gender. But in this example, you have an example, like we have a problem that the gender actually has some missing values. And so as a first step, we need to replace the missing values in the gender first, and then we can use the gender to replace the missing values in the weight and the height. So to replace the missing values in the gender, we can use the play basketball as our grouping like measure. So basically here, since like QWE, the player QWE plays basketball, so we can see who else plays basketball. So here we have a male, and then we have one female that plays basketball. So like two males and one female. So we go with like the most frequent, which is a male. So we're going to replace this with a male. Same here, this is a yes. So basically now we have like three males and one female. So the most frequent is a male. So basically here, this is going to be replaced with a male as well. Now we can use the gender to replace the missing values in the weight and height. So player ZXC, that player is a male. So we can calculate the average weight of males in our data set and replace the missing value with that average. For the height, we can do the same thing. So for player XYZ, that's the male. So we calculate the average height of all males and replace the value here. Same thing with ABC. And then RTY is a female. So basically we calculate the average height of all females in our data set and use that to replace the value in the height and so on. So now instead of just having a single value, replacing all the missing values, we can actually have multiple values because if gender has more than two values here, then basically instead of having just two groups, we're going to have like 3, 4, 5, 6, 7, 10 groups. And so we're going to have like the height instead of being just like the missing values in the height being replaced with just like two values, then they're going to be replaced by 10 different values depending on which group that player falls into. Okay. Another thing we need to worry about is the outliers, which basically are values outside the normal spread of a certain attribute. And usually an outlier is defined as a data point that has three standard deviations away from the mean, or 1.5 of the interquartile range from the median. Okay, so basically that's the formal definition of what an outlier is. Outliers can be easy to find sometimes, but they can be very hard to find other times. So for example, here we have an income distribution. We have the box and whisker chart. The line in the middle represents the median, and then we have the whiskers representing the quartile ranges. And then like you can see the outliers is way far from the rest of the values. And so you can identify these two data points as outliers. And in that case, that would require further investigation why these outliers happened in our data set. However, sometimes it's a bit tricky to find these outliers. So here, for example, if we just draw the height, like it seems like all the players in our data set have like consistent height. There are no outliers in the height. And then we study the weight as well. So you were doing our univariate analysis for the height, for the weight, and it seems like everything is within the same range. Everyone is in the same range. But then when we do like a bivariate analysis and we draw a scatter plot to basically find the relationship between the weight and height, we find some outliers. There are some player, like some data points with like low height and high weight, and there are some other data points with like high height and low weight. So basically these are outliers, and basically we need to separate them, study them separately to understand why these happened. There are multiple reasons for why an outlier might happen. One of them is basically due to incorrect input. So for example, like you might be studying like patients going to the ER, and then one of the records had a patient who was like 500 years old. Okay, so that would show when you're doing your univariate analysis, or like when you do like a box and whisker kind of chart. And the reason behind like having someone who's 500 years old, that's not because there is actually a person who's 500 years old. That's just because like an extra zero was added by mistake. So basically, the cause of this outlier is an incorrect input. In such a case, you can either correct it, basically treat it as a dirty data, correct it by removing the extra zero, or just like remove the entire value and like handle it as a missing value, right? And then use the missing value techniques in order to fill in that missing value. So that one approach for, or like that's one cause for outliers, basically incorrect input. And that in such case, we treat it as a dirty data. But the other reason is it might actually be because the data actually has some outliers. Some people might be like earning way higher than other people. And so like in your data set, you might find some outliers of people with net income that's very high, or like represents an outlier compared to the rest of the people in that group. And in that case, basically what we need to do is separate the data set. So we take these outliers out of our data set and build a different model for these outliers. So having these outliers in our data set would just like confuse the model and make the model like take longer to converge and like reduce its accuracy. However, separating these outliers from the data set, then basically that allows us to build a more meaningful model. That's, of course, unless you actually want to build a model to detect these outliers. In such a case, then you're keeping the outliers in your data set, and then you're training your model in order to detect these outliers. But that's a different scenario, okay? Other than like having charts to understand whether you have outliers or not, you can actually look at the statistics you're calculating in order to find out if you have an outlier or not. So this is an example here. So we have the same data set like 4, 4, 5, 5, 5, 6, 6, 7, 7. And then replacing just like one data point with an outlier like 300, as in like the column on the right, you're going to see that there are differences in some statistical measures. So for example, like without an outlier, the mean, the median, and the mod have pretty much the same value. However, with an outlier, you're gonna see that the mean have changed drastic. Like the mean has changed a lot, and comparing the mean with the median and the mod, you're gonna see that there is a huge difference between these values, and basically that's an indicator that you have an outlier in your data set. For spread measures, you can do the same thing as well, and you're going to see that the standard deviation and the range have been affected by having an outlier in the data set compared to the interquartile range. So basically, calculating the standard deviation and the interquartile range, comparing these values to one another, if they are very different from one another, then basically this means that you have an outlier in your data set, and you need to handle that before moving further with modeling. Okay. Then there are some techniques in order to transform the data set from one form to the other, because some machine learning models only work on numeric attributes and some other only work on categorical attributes. So basically, you need to be familiar with the techniques that allows you to transform a data set or like an attribute from being numeric to being categorical, and from being categorical to being numeric. The binning approach is one of these techniques that allows you to actually transform a numeric attribute into a categorical attribute. So having a continuous variable, transform that into a discrete variable. There are two approaches for binning. The first one is equal width binning, where each bin has the same range. And there is the equal density or like equal frequency binning, which basically has like the bins have different ranges, but each bin has an equal number of records in it. So in this example, we have attribute age that has a number of values. And then if you want to use like the equal width binning, then we can create 3 bins. Each bin has a size of 10. And that would mean that bin 1 would have like patients of age 0 and 4. Bin 2 would have like patients of age 12, 16, 16, and 18. And the third bin would have patients of age 24, 26, and 28. As you can see, each with equal width binning, each bin has an equal width. So basically it has the same range. However, like the number of records falling in each bin is different from one another. And now instead of like having an age as a continuous variable, as a numeric variable, we can replace that with age, the discrete, like the categorical variable, where instead of like basically writing that this patient's age is 4, we can say that this patient age is in range 1. And instead of saying like this patient age is 18, we can say that this patient is in age range 2, like basically replacing the number with the word range 1, range 2, range 3, or whatever representation you can represent it with, a text representation or a discrete representation for that range. With equal density binning, basically, like the ranges would have different, the bins would have different ranges, but each bin would have an equal number of records in them. The the binning approach can also be used to do some smoothing to the different values. So like even if you don't want to convert a numeric attribute to a categorical attribute, you can still use the binning approach, and instead of replacing the bin with a number, or sorry, with a text with a range, like range 1, range 2, or whatever, you can replace the bin values with the average of that bin, for example. So basically, like if someone ages 0 or 4, then you're going to replace that with the average of that bin, which goes from like 0 to 10. So the average is going to be a 5. Anyone from the age 10 to 20 is going to be replaced with the value 15. And anyone from range 20 to 30 is going to be replaced with 25. Okay. So again, like that would create a discrete set of like numeric values that basically would make it easier for the machine learning model to train on them, and it would like make it converge faster because it has to go through like a fewer values as opposed to just like any number between 0 and let's say 200 or 150 for the age. Okay. So binning is an approach that can be used to transform numeric attributes to categorical attributes, or it can be used to smooth the numeric attributes and reduce the range, or like not the range, but like the values of that attribute. Okay. And then we have the scaling. So scaling is another important feature engineering approach that you can use on numeric attributes. Basically, numeric attributes come with different ranges. So age can go from 0 to 150, while another test might has a value of like from like 0 to like 10 to the negative, I don't know, like 10 or something like that. So basically, some tests might have like the results might have like the numeric results of a certain test might be very small. And if you use the values as is, that would cause the model to basically just ignore the attributes that have small values and base its decisions on the attributes that have huge value ranges. And that's why we need to use scaling when we're dealing with numeric attributes. So basically, what scaling does is that it transforms the values for all the attributes to be within the same range. So instead of having age between 0 and 150, we can use scaling so that the age becomes between 0 and 1. And instead of having a test that has the values between 0 to 10 to the negative 10, we can also transform that so the values are between 0 and 1 as well. So now both of these attributes would have the same impact on the decision made by the machine learning model. And now like the machine learning model task is simpler because all what it needs to do is to calculate the coefficients in the equation that basically would add the importance for the different attributes, but it will not be affected by the actual ranges of these attributes. There are two standard approaches for using for doing the scaling. There is the min-max normalization, which basically allows you to specify the range that you want to transform your attributes to. Usually it's between -1 and 1 or 0 and 1. And also there is the standardization or the Z-score scaling, which basically would transform your attribute to values in the range between -3 and 3. It doesn't matter which of these approaches you use, as long as you're using the same approach on all of your numeric attributes in your data set, then you're fine. So this is not to remove outlier. This is just like to make sure that all the numeric attributes contribute the same amount in the decision making afterwards. Because if you have an attribute that has a range that's very small, then its impact on the decision made by the machine learning model will not be like basically the machine learning model will just ignore it because like its values are very, very small, as opposed to like an attribute that has a range that's very big, right? So the purpose of the scaling process is to make sure that all numeric attributes are contributing the same to the decision making or like to building the machine learning model afterwards. Okay. Also, machine learning models work faster, basically converge faster or like train faster when the data is linear to what you're trying to predict to the target attribute. So if you can help with that, then that would speed up the processing of your machine learning model. So again, like depending on the visualizations you've done in the data understanding. So if you have something like the uh, let me just, yeah. So something like this, where basically you can see that like y equals e to x, right? So basically what you can do here is that you can just like take the log of the values. So now the relationship between the dependent and independent attributes become linear. Here you can see that the relationship between like y equals x squared. So basically what you can do is that you can take the square root of it so that the relationship between them becomes linear. And the same thing here, like y equals 1 divided by x. So you can do this in order to change it to linear and so on. So, so basically the idea here is that if you can transform the relationship between the dependent and independent attributes to linear, that would speed up the training of your machine learning model. It's like it's not a must, but it's just like something to speed up the training and make your models more accurate. Same thing with the distribution. So if your model, sorry, if your data is not balanced or like it does not follow the normal distribution, then it would take longer for the machine learning model to train on them. So if you can like normally distribute your data set or like remove any skewness in it, then that would speed up the processing as well of your machine learning model. So if your data set is right skewed, you can use square or cube root or the log in order to balance it. If it's left skewed, you can use the square or the cube or the exponential of your variable in order to balance it as well. And that would like speed up the machine learning model training. In terms of transforming a categorical attribute to a numeric attribute, so things like neural network, for example, they don't work with categorical attributes. So in that case, you need to transform them into a numeric attribute. And the way for us to do that is using something called the dummy encoding or one-hot encoding. In that case, each of the values we have in our attribute, like here we have a number of values. So give me a second here. Yep, here we go. So here we have the province, and the province has values Ontario, Saskatchewan, Newfoundland, and Manitoba. And basically, if we want to transform that province categorical attribute to a numeric attribute, what we do is that we create a column for each of the values we have for this attribute, and then the value here becomes a 0 if that patient does not do not live in that province, and becomes a 1 if that patient lives in that province. Okay, as you can see here, like we don't have a column for Ontario because it's like it's already known that like if all the values are zeros, this means that this patient lives in the missing province, which is Ontario here. So the Ontario column is just like adds redundant information. And so like there is no actual need for us to have it here. So if we have n provinces, then basically we have n minus 1 columns added when we're doing the dummy encoding or like the one-hot encoding. Okay, and here there are ways for us to reduce the amount of attributes we create. So there are methods for combining multiple attributes in order to make like the process of training a model easier. One of these approaches is called the principal component analysis, which basically creates a linear combination of the different attributes uh, that basically has like that can be used in order to differentiate between the different records easier. So in this example, we have 17 dimensions, or basically 17 attributes in our data set. And we're trying to differentiate between people in England, North Ireland, Scotland, and Wales, depending on their eating habits. And looking at the 17 dimensions, it's hard to tell like who's from where, depending on what they eat. However, if we calculate the principal components, then we can generate 17 principal components, where the first principal component has the most data, the second principal component has less data than the first one, and the third principal component has like less data than the second one, and so on, until like we reach the 17 principal component, which has like the least amount of information there. So instead of just like keeping the 17 principal components, we only need the first, or maybe like the first and second principal components to actually represent this data. And that's what we see here. So with the first principal component only, we can see that like basically like we can define that like if there's any person who scores or their first principal component is like more than 200, then that person belongs to North Ireland. If that principal component for that person is like between negative 125 and 200, then that person is from Scotland. Between negative 200 and negative 150, that person is from England, and so on. Same thing if we're using two principal components. So first principal component, the second principal components. And so we can just like draw lines here and say anyone falls on the right side of this line belongs to North Ireland. Between these two lines belongs to Scotland. Between these two lines belongs to England. And on the left of this line belongs to Wales. So basically, we can run a machine learning algorithm to come up with the coefficients for this line, for this line, for this line, which basically are going to separate the people from the different places. And now, like, the problem is way simpler than having to look at 17 dimensions and having to like having the machine learning model trying to figure out how to like draw these hyperplanes in 17 dimensions. Now the problem is easier because now we are only working in 2 dimensions. So solutions like principal component analysis can help doing that. Basically, it does projection of a high dimensional space into a lower dimensional space, which basically can help a machine learning model train and generate better results. The main issue with this approach is that you cannot justify the decisions made. So for example, like here, if there is a new person that basically when you calculated their principal component, like the first principal component, second principal component, they fell at this point. And you built a machine learning model that basically generated these lines, right? Or like these classifiers. Now you can say that since this point falls to the right side of the first classifier, this means that this person is from North Ireland. However, like if someone asks you, like, why do you think, like, what are they eating, that made you think that they are from North Ireland, you won't be able to answer this question. Basically, what you can say is that like that person is from North Ireland because like their like first principal component is like here and their second principal component is here, and that falls to the right side of this classifier, which doesn't make much sense. Like, yes, like you correctly classified that person, but you cannot give a justification of why you made that decision, because like you lost all the information about their eating habits once you do the transformation or the projection of that high dimensional space to that lower dimensional space. So that's one of the the issues with like using principal component analysis. One way of handling this is basically instead of just like using the principal components to build your machine learning model, you can do a combination between the principal components and some of like the original attributes. So that way, basically, when like someone like falls in this region, you say, yes, they're from North Ireland because basically they are eating like more cereal and like less fresh fruit, for example. Okay. So that's like one way of like building an accurate machine learning model, and at the same time being able to give a justification of why you made that decision, or like why like you made that classification. Okay. So basically the principal components are based on the eigenvalues. So it calculates the eigenvalues based on like this matrix, the 17 dimensions, right? And they use and then the eigenvalues are used in order to create the first principal component, the second principal component, and so on. Yeah, like in a simpler terms, basically like a principal component is just like a linear combination of these attributes. Basically, it's some attribute plus something multiplied by the second attribute minus something multiplied by the second attribute, and so on. Okay. So for data preparation, you start with data cleaning first. You identify the dirty data, try to detect them, and treat them as missing values. Try to detect the outliers by either using statistical measure comparing the mean to the mod, or comparing the standard deviation with the interquartile range, or using visualizations to detect if there are outliers. And then you decide whether that an outlier is caused by an incorrect input, in that case treated as a missing value, or it's caused because, yes, like my data has these values and these values are okay in my data set. In that case, either build a model to detect the outliers if that's what you're trying to do. If not, then basically remove the outliers from your data set and build a model, a separate model for them, if you want. For missing data, you can delete the entire column, the entire row, depending on how much how much missing data in that column. But that's basically your last resort. And then what you can do is replacing these values with either like a statistical value or a grouped statistical value. Once you do your cleaning, then you can do some transformations to numeric transformations, like creating or doing scaling, doing grounding, making it linear, making it symmetric. Or you can also to transform a numeric attribute into a categorical attribute using binning approach. For categorical attributes, you can group values together. So let's say like you have lots of patients in a Canadian hospital, and some of them are coming from the US or like other countries. So basically, like most patients are going to be from Canada, and instead of just like saying the actual country of the other patients that are not from Canada, you can just like have a value that says other countries. So basically, that would group all like anyone not from Canada into that other group. That would simplify the process, or like the training process for the machine learning model. You can also transform a categorical attribute to a numeric attribute using the dummy encoding or the one-hot encoding. After you do your transformation, then you can do your engineering, which basically creating new features or like new attributes. So you can do a lot of stuff. You can sum, you can subtract, multiply, divide, create ratios, create flags like this, like these purchases happened on like Boxing Day, or like these happened after a certain like the day after taking a certain drug, and so on. So basically you can have a number of flags there. And once you do your feature engineering, then there's the feature reduction or the feature selection part. There are multiple techniques. There is the principal component analysis. There is another approach similar to the principal component analysis called the TSNE. It's basically works like using the same principles of like doing a projection from a higher dimensional space to a lower dimensional space. Then you can do some feature selection, like removing features with unique value or one value. So basically something like a phone number, it always has a unique value. Each row or like each patient would have like their own unique phone number. And so like you need to remove that column. It doesn't add much information. You can generate more features out of it, but then the phone number column, it doesn't need to be there. So you remove that one. Features or columns with like one value. So basically, if all your patients are from Canada, then there is no point of keeping a column for a country. Highly correlated or not correlated attributes. So basically, if of if like attributes are not correlated with the target attribute, the thing you're trying to predict, then you can remove it. Also, like attributes that are highly correlated with the target attribute, then you can remove it as well, because like they add redundancy in your data set. Okay. So that's basically a summary of the different data preparation techniques that we can use in order to prepare our data for modeling afterwards. Okay. So as you've seen, basically we go to mybinder.org and then we'd copy the URL, the GitHub URL here, and then click the launch button to open the Jupyter notebook where we can run the code for this hands-on exercise. Perfect. Okay. So Jupyter Notebook, basically, it gives you the space to write code, run it on a remote server without having to install anything on your computers. And yeah, like, so basically what we're gonna open here is the data preparation notebook. So just double click on it to open a new tab. And on this hands-on exercise, what we're gonna do is that we're gonna get some data from Airbnb San Francisco, and then we're gonna look at the data we have, and then we're gonna run some data cleaning, data preparation steps in order to generate a better data set that we can use later on in modeling. So the way Jupyter Notebook works is basically it has a number of cells. So basically this is a cell and then this is a cell and so on. And then in each cell, we can either write a markdown text, so basically just text describing what we have, or we can write code or commands that can run, okay? So when a command starts with a percentage sign, this means that this is a Linux command. So you're sending that command to the underlying operating system. And ls, this is the command for listing the files in the current directory. And so basically when you type ls here and then click the play button or run button, what it does is that it's going to run, and then it's going to show you the files in the current folder, which are basically the 3 files, okay? We have a README file, and then the notebook, which is we're running right now. And then we have a CSV file that has all the data from Airbnb. You can also double click the file here. It says V file, and it's going to open and show you the data we have here. Okay. So basically each of the listings, Airbnb listings, it has an ID, a listing URL, and a number of attributes, as you can see here. Okay. Okay, so one package that's very important when we're doing data preparation and machine learning is called pandas. And basically this package allows us to manipulate data and do like lots of like data preparation, data understanding processes on them. So to install a Python package, basically we use the pipe install pandas, and then we add an exclamation mark here because basically this is not a regular Python command. It's a command for installing packages. So basically pipe install pandas, and then we click run. It's going to take a while to download all the packages and install them on our platform. Once we do that, in order for us to use pandas, we need to import it. So we do import pandas. And then since I'm lazy to like write pandas every time, so we're giving it an alias using the as keyword and then PD. So instead of having type pandas dot every time, I can now do like PD dot to speed up things. If you want to know more information about anything in Python, then basically you can use the help function, help, and then give it what you're looking for. So basically here, help pandas or help PD, since PD is an alias for pandas. And then it's going to give you all the information you need about what pandas is and what it can do. Now let's try to read the Airbnb listings CSV file into our code. So here we're going to do pandas.read CSV and give it the path to our CSV file. And that basically would make the code read the file from the disk and then create a table or a data structure within our program that holds this data. So now our data is stored in a variable called raw data frame. And in order to display that, in order to display it, to display that data frame, basically we can do dot head. And dot head basically is just going to display the first 5 records. So these are the the first 5 records. Basically, it has an ID and some columns. And since like we have 96 columns in our data set, it won't be able to display the entire thing. So basically it displays some columns, and then like you have the 3 dots, which means there are like more columns here, and then there are the rest of the columns. Okay. So if we want to know like how many records and how many columns we have, we can use dot shape. So basically it tells us that we have 7,072 records, and each record has 96 different attributes and 96 columns. If we want to list the name of these columns, then we can use dot columns, which is going to display the names of all 96 columns in our data set. Also, we can use .info in order to get more information about each of the columns or each of the attributes we have, and basically tells us what is the data type. So float 64, this means that this is a numeric attribute, and an object, this means that this is a categorical attribute with discrete values. It also tell us like whether there are non-null in the data set or not. So basically, a 0 non-null, this means that basically all the data for this column are nulls. So basically all the data in this column are missing, okay? So later on in our data preparation step, it makes sense for us to just like delete this entire column, since basically all its values are nulls. However, we have like other columns, things like the ID or the listing URL or whatever. Basically, they have 5,165 non-null values, which means that we have some missing values there, right? We have almost like around like 1,900 missing values in the listing URL and the ID and so on. So basically, like we like 1,900 is the big number. However, it's not close to like 80 or 85%. So we're not going to delete these columns. We're just going to try to fill in these missing values with things like the most frequent or things like the average of that column. Okay. So since like we have 96 columns here, like, and this is just an exercise, so like we don't actually need to keep all these columns to speed up things. And so basically we're just going to keep some of these columns, and that can be easily done using the selection mechanism Python offer, which basically raw data frame, it can be treated like an array. And then if you give it an array of the columns you want to keep, then basically it will just like keep these columns and ignore the rest of them. So here we have a list or an array of the column names that we want to keep. And then here we select these columns from the raw data frame and create a new data frame that consists only of these columns. Now, if we display the base data frame or the new data frame that we've just created, now like we have 25 columns in our data set instead of the 96 columns. And these 25 columns are basically these ones. You can use it like D types as well, .d types, in order to get the data types of each of the columns you have, or you can use the .info as well in order to do the same thing. So there are multiple ways to do the same thing in Python, which makes it really flexible. Okay, so let's try to fix the data type for the price. So price here, it says it's an object, which means that Python thinks that the price is actually a categorical attribute with discrete set of values. However, that's not true. We know that the price is actually a numeric variable. So we want to change the data type for price from being an object to being a float 64. So first, let's like see the values we have in the price. So you can see that price consists of a $sign, a number, and some of them has nan or not a number, basically null or like a missing value. So the first thing is basically we want to replace these $signs with nothing, because basically a $sign is a character, and that's why Python thinks that the price is actually a categorical attribute and not a numeric attribute. So let's remove that dollar sign. And to do that, like we can use the replace method. And so basically here we do base data frame dot replace and then the price column. And we're going to use regular expressions, search for all the dollar signs and replace them with nothing. Okay. So basically we run this line and that basically go through all the values in our price column and replace all the dollar signs with nothing and store the results in a new data frame called the fixed price data frame. Now, if we use the head method again, price.head method again, then basically now you see all the values do not have any dollar signs anymore. When we type data types, you still see that the price says object. So basically Python does not do automatic data type transformation. So now we need to do it manually. And it's very simple. All what we need to do is just like use the as type and then give it the data type we want to convert to. So fixed price data frame of price as type float. So basically get the price column from that data frame and try to transform it to the float 64 data type. Okay, store the results in this fixed data frame price. So basically override the values in that data frame. However, if you try to run it, it's gonna you're gonna get an exception, and at the end of the exception is gonna tell you could not convert string to float 1,100.00. So basically here, since there is a comma, Python was not able to basically process this value and transform it to a number. Okay. So what we need to do now is, as we did with the dollar sign, we need to also find all the commas and replace them with nothing as well. And that basically would allow Python to do the transformation of the price values from being strings or being text to being numbers. So all what we need to do is going back to the replace method and here replace all the dollar signs, replace all the commas with nothing. And we run that. And now when we do the as type float 64, we don't get an error. And when we do the data types, you can see here that the price now becomes a float 64. So now we've changed the data type of price from being categorical to being numeric. So now it's time to calculate some statistics to see how the central tendency and the spread of our attributes. And to do that, we use the describe method. Okay. Again, if you want to know more information about how to use describe, then you can use help in order to give you all the information you need on how to use that method here. So basically, I want to know more information about certain attributes. Host is a superhost, host total listing count, and a zip code. So basically, here I'm creating a subset of my data frame by adding mentioning the columns that I'm interested in, and then doing .describe to only describe or calculate the statistics for only the 3 columns out of the 25 columns we have left. But as you can see, the results here only display 2 columns, which are the host total listing count and the zip code. And the reason here is that unless you explicitly mention that you want all the columns, then the describe method would only calculate statistics for numeric attributes only. Because here you're calculating the count, the mean, the standard deviation, the quartiles, the median, and so on. And so these attributes do not, or these measures do not make sense for categorical attributes. However, there are other attributes, things like counts, unique, and so on, that make sense for categorical attributes. So in order to force Python or the describe method here to actually calculate statistics for all attributes, including categorical attributes, all you need to do is say include equals all as a parameter to the describe method. And in that case, basically, it will just display statistics for everything. For categorical attributes, things like host is a superhost is going to calculate the count, how many values that are not null, and then how many unique values. Basically here we have true or false, so T and F. And basically it's going to tell you you have 2 categories in this categorical attribute, or 2 discrete values in this categorical attribute. Top, which means the most frequent, is F, which is false. So basically most listings are not superhosts. And the frequency is 3,000. So 3,000 out of the 5,000s are not superhost or like false for superhost. And then for all the other statistical measures, just going to be not a number, not a number, not a number, because this is a categorical attribute. If we move to a numeric attribute like host total listing count, you're going to see that like it has the count. And then for the unique, top, and frequency, you have not a number because basically these are numeric attributes, so we cannot calculate these measures for them. However, for the mean, standard deviation, minimum, first quartile, median, third quartile, and max, basically you have values here that represent the statistics or like the standard, like the central tendency and the spread of that attribute. Okay. So all what we need to do is just like in the describe method, we just say include equals all. Okay. So nulls or like missing values. So one thing we can do is basically just dropping the entire column or the entire record that has missing values. Okay. Or like in Python, it's called NA. So not a number, nan, or so the way to do that is there is a method called drop NA, and we can use that basically to drop any record that does not have a zip code. So here we're gonna do our data frame, fixed price data frame, the drop NA subset equals zip code. So basically, if any record does not have a zip code, then basically drop that record from our data set. Okay. And then we do our describe again, and you can see here that the number of records has been reduced a bit because now like all records with no zip codes have been removed from our data set. Okay. Now instead, like starting with like 7,070 something records, now we only have 5,101 records. And you can see here that like most of the attributes have no nulls or like no missing values anymore. So here like we have 5,101 non-null, so like no missing values since all the records we have are 5,101. However, like you're gonna see like some attributes still have some missing values, like the number of bathrooms in a listing, still like there's around 20 missing values here and so on. So let's try and fill these missing values with something. So in order to fill a missing value, we can use the fill NA. So fill not a number or fill nulls or fill blanks, basically, or fill missing values. And basically what we're going to do here is that we're going to say fill our data frame dot fill NA, and then we're going to fill it with the median of that column. Okay. So basically get the median of a certain attribute, and then if there is any missing values in that attribute, then fill it with that median. And now when we do the inf one more time, so remember the total records we have is 5,101. Now like all the columns or all the attributes have 5,101 non-null. So this means that we don't have any missing values anymore in our data set. Okay. And then let's take a look at outliers or extreme values. Yep. So media is asking, could we fill it with the mean? Yes, we can. So basically, all what you need to do is instead of like median here, you need to replace this with mean. Okay. You can replace it with any value. You can actually have a constant value here. So basically, if I just like remove this and just like add 33, then it will just like replace all the missing values with 33. Okay. So now let's look at outliers or extreme values. So for the price, we can do price.describe, and that basically will give us like the maximum, the minimum, along with other values. So you can see here that like someone is basically putting their listing on Airbnb and not charging any money. And that doesn't make much sense. So basically that's probably an incorrect input or like an outlier. So let's like remove any records that do not make sense. So let's just like remove any record that like where like the person is not asking for any money for their place. So we can use the query method to do that. So here we're gonna say impute, or like our data frame dot query price greater than 0. So basically Return all the records where the price column or the price attribute is greater than a 0. And that would like create a new data frame where all the prices or like all the listings have a price that is greater than a 0. Okay. So basically that's how we select certain records based on a certain condition, which is here the price is greater than a 0. We can also take a look at the minimum nights required to book a certain listing. So here we can see that like the minimum nights is 1 night, and the maximum is like, I don't know, 100 million nights as a minimum stay, right? Which does not make much sense. So again, we can use the query method in order to just like ignore or like remove certain values. So we can do that where basically if anyone is asking for like more than 1 year of a minimum stay, then just like ignore this listing because like this probably is because of like incorrect input. And so we can use the dot query method to basically only return the records that have minimum nights less than or equal 365 days. Okay. And that's basically would ignore anything that is asking for more than 1 year as a minimum stay. Okay. And then let's look at how we can transform a numeric attribute to a categorical attribute. So let's say we want to see if the price, instead of being a numeric attribute, we want to actually like categorize the different listings into whether they are cheap, moderate, or expensive. And to do that, we can use the binning approach that we've talked about in our workshop. And to do that, we use the cut method. So pandas.cut, and then give it which column we want to cut or like basically to split into bins, specify how many bins we want, and then like how to label these columns or like these new attributes, sorry. So basically here we're going to label them cheap, moderate, and expensive. In the slides, we named them range 1, range 2, range 3. Here we're going to like label them cheap for the first bin, moderate for the second bin, and expensive for the third bin. And basically, once we do that, we're going to store the results in a new column called binned price. And then we can display it. So here you can see, here we have the price column and then the binned price, which is the column that we just engineered or the attribute we just engineered. Now, like it has the word expensive. Here we if we do a count, we have like 3 expensive listings, 4 moderate listings, and 5,089 cheap listings. That's of course because we here like we were only using 3 bins and these are equal width binnings. So yeah, like so basically that's how we ended up with this. Okay. So let's do the opposite now, basically transform a categorical attribute to a numeric attribute. So here we have a room type, and here the values this is a categorical attribute with values that are entire home, private home, or a shared room. So basically these are the 3 discrete values for room type. And we want to transform that to a numeric attribute. So using hot encoding, what we're going to do is that we're going to create a column for private room and another column for shared room. If the value is entire home, then both of these columns are going to get zeros. If the listing is a private room, then private room is going to get a 1 and a shared room going to get a 0. If it's a shared room, then a shared room is going to get a 1 and a private room is going to get a 0. Okay. So in order to do that, then basically we're going to use the get dummies, which basically is going to run a dummy encoding or like one hot encoding on the room type. So basically get dummies on the room type. And for the new columns created, add a prefix of room type. Okay. And drop first. This means that like don't create 3 columns for the 3 discrete values here. Drop the first column or like drop the first discrete value. So only keep like these 2. Okay. Because like the first one is just like being redundant. So once we do that, then basically now we have 2 new columns. So here we have room type, which is the prefix we have here, and then private room, which is the value. And then here room type shared room, which is basically this. So if it's 0, 0, this means that this listing is an entire home. If it's a 1, 0, then basically this means this is a private room. If it's a 0, 1, then this means that this listing is a shared room. And that's basically how we can transform a categorical attribute to a numeric attribute. Okay, so basically, once you're done cleaning up your data, doing your transformations, generating new attributes out of the existing ones, then what you'd need to do now is saving your data. So again, use pandas for that. So your data frame dot to CSV, and then give it a path to save your data. And that basically would save the cleaned, prepared data set into that new file. And basically, in tomorrow's workshop, we're going to see how you can load that file and use that data into like to train a machine learning model and basically generate insights. So yeah, so basically that's the hands-on exercise for today. Are there any questions related to the hands-on exercise or the workshop in general? And thanks everyone for joining us today. And yep, and I hope to see everyone tomorrow in the machine learning workshop. Thanks everyone.